This is May 2016, paper 2, time zone 1, question number 9. And it's a question, it's not obvious, but it's a question about viettes. What should give that away a little bit is that there's no information about A and B given, and in fact, if you read the whole question, never asked to find A and B. So that tells you that we're only really dealing with some of the information here. And although it is possible to find A and B with the information that you've been given, it's not necessary. Right. First question is find the other two roots in terms of C and D. Well, we've got these two roots, so the other two roots must be, part A, they're complex conjugates, C minus I and 2 minus ID. Because if the polynomial, the red polynomial, has real valued coefficients, then its roots must form complex conjugates with each other. Okay, part B, find the value of C and D. And this is where Viet's comes into play. We know from Viet's formula that if you multiply, in this case there are 4 roots, alpha, beta, gamma, delta. If you multiply them together, you will get 50, the last coefficient. And if you add them together, you get minus 10, so 10. Now, since we know the 4 roots in terms of C and D, we can set up 2 equations, 2 unknowns, we should be able to find them. But it actually turns out to be a little bit easier than that. You might have spotted, if you add 2ID and 2 minus ID and 2 plus ID together, the D's are going to cancel out. So let's start with the red one and just add up C plus I plus C minus I plus 2 plus ID plus 2 minus ID equals 10. Collect that together, we get 2C plus 4 equals 10. And that's an easy equation to solve. 2C is 6, C is 3. Then to find D, we'll use the black equation, Viet's formula, alpha, beta, gamma, delta. 3 plus I times 3 minus I times 2 plus ID times 2 minus ID equals 15. If we think about these complex conjugates in pairs, 3 plus I times 3 minus I, the imaginary parts will cancel out, so that's going to be a real number, and 2 plus ID, 2 minus ID, the imaginary parts are going to cancel out, it's also going to be a real number. You could even evaluate this on your calculator, 3 plus I times 3 minus I. However you did it, you'd find it's 9 plus 1 is 10. And if you do the 2 plus ID bit, you get 4, the imaginary parts cancel out, plus D squared equals 50. Which gives you 4 plus D squared equals 5, dividing both sides by 10. D squared is 1, and D is 1, because you're told in the question that it's greater than 0. So there's your 2 answers. C equals 3, D equals 1.